Good morning, everyone. So it's AP1, September 8th, period 6. I am going to wait until we have 30 concurrent viewers, and then I will start. So we'll get started in just a moment. Still waiting on some people. We're up to 12 viewers, waiting on 30 viewers before I start the class. Let's see, how many are we at? Hello, everyone. We're at 18 concurrent viewers. We'll wait at most 2 more minutes, and we'll wait for 30 viewers. You could submit your attendance at this time. Now would be a great time to submit your attendance for the day. Waiting for 4 more viewers. There's a request to see the dogs. Bug is sleeping right next to me, so I will show Bug. Here's Mr. Bugs. And he wants to go back to sleep. Oh, Bugs. Oh, Bugs. It's like a baby, kind of. Oh, Bugs. Can I get a num-num? Can I get a num-num? Good boy. Okay. Are we at 30? We're not at 30, so I'm just going to start. And because we have a finite amount of time. And if you know someone who should be watching this but is not, send them a text message. All right. So this is AP Physics 1. And let me just talk about what we learned on Friday. On Friday, we learned about displacement, which is denoted by delta x. It's the change in position. And it's equal to final position minus initial position. That is the displacement. We also learned about distance traveled. There's a question, how do we do the daily attendance? We do the daily attendance by going onto the Canvas page, and there's a button called Daily Attendance. It'll take you to a Google form, and you type in your student ID on the Google form. Okay. Distance traveled is slightly different from displacement. It's for distance traveled, let's say you walk forward 5 meters and you walk back 5 meters. In that case, your displacement would be 0 because your final position is the same as your initial position because you walk forward and then you walk back to the same spot. However, if you walk forward 5 meters and back 5 meters, that is a distance traveled of 10 meters. So the distance traveled is kind of like what your odometer would read. Okay? And then lastly, we learned the equation for velocity. Velocity is displacement over time. Okay? So that is velocity. All right. So now we're going to learn some new stuff. And to learn the new stuff, we're going to have an example. And this example comes from my morning. So I woke up. So I'm going to represent my journey this morning on a number line. So I woke up at coordinate x equals 0. And then I walked forward to x equals 7 meters. And that journey took me 3 seconds. Okay? But it was the morning, and I was really groggy. And so once I got to x equals 7 meters, I just kind of spaced out and stayed put for 4 seconds. For 4 seconds, I did nothing. I just kind of, I don't know what I did. It's lost. That memory is lost. And then I remembered that what I wanted was actually on the other side of the room. And so I walked over to x equals minus 3 meters. And that took me 2 seconds. Okay? And so this is going to introduce us to the concept of instantaneous velocity. Okay? Instantaneous velocity is the velocity at a particular moment. Okay? So this journey has 3 different parts. It has a part that lasted 2 seconds, a part that lasted 4 seconds, and a part that lasted 3 seconds, 4 seconds, and 2 seconds. So that means that I had 3 different instantaneous velocities. It's kind of like if you're driving around, your velocity is not going to stay constant. You're turning, so you're changing directions. You are speeding up and slowing down. So at a particular moment, you have a certain speed. That's your instantaneous velocity. Okay? So what if I wanted to know, what is the instantaneous velocity at 2 seconds into the journey? 2 seconds into the journey. So does that mean that it's this portion? No, this portion of the journey took 2 seconds, but during the first 2 seconds, I was on this leg of the journey, okay? So I want to know, what was my velocity for this leg of the journey right here, okay? So how far did I travel during those first 3 seconds of that journey. I traveled from 0 to 7. So that's a displacement of 7 meters. And how much time did that take? Well, the first segment took 3 seconds. Okay, and so that means that my instantaneous velocity 2 seconds into the journey was 2.3 meters per second, plus 2.3. Okay, the reason I'm going to put a plus on there is because I want to make sure that velocity, because velocity is speed with direction. So I want to emphasize that there is a direction to that, so I'm going to put a plus there. Okay. Very good. Okay, so now what I would like to know is what is the instantaneous velocity at 5 seconds into the journey? And that's a really easy question. So I'm going to ask that if you know the answer, go ahead and type it into the live chat. And while I do that, I'm going to, so if you know the answer, what was the instantaneous velocity at 5 seconds, type it in. And I'm going to go ahead and set up the problem that we're going to have after this, which is the instantaneous velocity at 8 seconds. So I see that some people are typing in 0, and that is correct. Okay, 0 meters per second. Why is it 0 meters per second? It's because 5 seconds into the journey, I was spaced out, just at rest here at x equals 7. So I wasn't moving at all. So my instantaneous velocity was 0. Very good. All right. Go ahead and if you know the displacement for the third segment, so 8 seconds is the third segment. How do I know that? Because the first segment was 3 seconds. Then the next one was 4 seconds, so I'm 7 seconds into the journey. So then 8 seconds would be during this part. So I want to know what is the instantaneous velocity for that part. So if you know the displacement for the third part, go ahead and type it in. If you know the displacement for the third part of the journey, the time elapsed is going to be 2 seconds. So I'm going to wait and see if someone knows what the displacement was. Oh, you guys just went to the final answer. Yeah, so if you go from 7 to -3, that's a displacement of -10 meters. Okay, -10 meters in 2 seconds, that is -5 meters per second. So that is the velocity for the second part of the journey. Okay, or the third part, excuse me. All right, so that's instantaneous velocity. It's your velocity at a particular instant. But then we could also talk about average velocity. Okay, average velocity is your total displacement over the total time elapsed. Okay, so if you know that, and so we're looking at the journey as a whole. If you know the total displacement, I want you to type it into the live chat. And while you think about that, I'm going to tell you something about the difference between average velocity and instantaneous velocity. Okay, so my family lives in Washington State. And Washington State is, where I live is about 1,100 miles north of where we are currently, okay? And when I drive up to Washington, it takes me about 18 hours to do that drive. So if I go 1,100 miles and it takes me 18 hours, that's an average velocity of 61.1 miles per hour north. Okay? But does that mean I was going 61.1 miles per hour north the entire journey? No. If I was on the freeway, I was probably going more like 85 miles per hour north, okay? If I could get away with it. But there were times when I got stuck behind a truck, where I stopped to eat or go to the bathroom, and those lowered my average velocity, okay? So I can see that many of you have typed in -3 for the total displacement, and that is correct. Why? Because you start at, so looking at the journey as a whole, you start at x equals 0, you end at x equals -3. So you went 3 meters to the left. That's a total displacement of -3 meters. And then the total time elapsed would be 3 seconds for the first part, 4 seconds for the second part, and 2 seconds for the third part. That's 9 seconds total. So our average velocity is minus 0.3 meters per second. So I'm putting that negative sign in there to indicate direction. Okay. Now, why is the average velocity so close to 0? It's because I wasted a lot of time going in to the right. When I ended up going to the left, I wasted time going to the right, and I wasted time just sitting there. Okay. One thing to keep in mind about average velocity is the average velocity is not 2.3 plus 0 plus -5 over 3. That is not the average velocity, okay? Because the average velocity takes into account the amount of time you spend at each speed. So for example, if I spent 1 minute at rest and then an hour at 100 miles per hour, my average speed is not going to be 50 miles per hour because I spent so much more time going close to 100 miles per hour. My average is going to be skewed towards 100. Okay? So that leads me to the next concept. So we have two new concepts today. We have instantaneous velocity, average velocity. Now let's talk about average speed. Average speed is total distance traveled over total time. Okay? So go ahead and type into the live chat if you know what the total distance traveled is. And the total time elapsed is going to be the same as before. So the total time elapsed is still going to be 9 seconds. And I'm waiting for someone to type in the total distance traveled. Someone types in 17. Very good. The answer is 17 meters. Someone typed in 10. So 10 is the distance traveled for the third part. But when we're looking at total distance traveled, we go forward 7 meters and then we go back 10 meters. So you add those two numbers together and we get 17 meters in 9 seconds. So 17 over 9 is about 1.9 meters per second. When we quote a speed, we don't need to worry about putting the plus or the minus because speed does not have direction. Okay? Let's do another example just to make sure everyone is understanding. So let's say a car travels at, let's say, 40 miles per hour for 1 hour. Then, at 60 miles per hour for 3 hours. Okay? Oh, and I'll put some directions in here. We'll just say east and east. Okay? So first of all, what is going to be the instantaneous velocity at half an hour into the journey? This is so one of the things we want to keep in mind for this problem is I'm giving you a velocity and a time. This is a velocity and this is a time. So, the question actually just straight up gives you the answer, because half an hour into the journey is when you were going 40 miles per hour. So the answer would be 40 miles per hour east. Okay. What about the average velocity for the entire journey? Well, that's going to be total. Uh-oh, my pen's running out of ink. I need another pen. Trash that one. Let's see if this one writes. Ooh, yeah. Total displacement over total time. Okay? So keep in mind, if you were to just average 40 and 60, you would get 50. 40 plus 60 over 2 is 50. Okay? But that's not going to be the answer. Who can tell me? Is the answer going to be closer to 40 miles per hour or 60 miles per hour, and why? If you know the answer to that, go ahead and type it in. I'm going to go ahead and calculate the displacement for the first part. The displacement for the first part, I use velocity as displacement over time. Okay? And the velocity is 40. The time is 1 hour. So that means that my displacement is 40 miles east. Okay? For the second part, for the second part, I go 60 miles per hour for 3 hours. So that means a displacement for the second part of 180 miles. Okay? So my total displacement was 40 miles plus 180 miles. That is going to be 220 miles is my total displacement. Okay? What is the total length of the journey? The total length of the journey is 4 hours. So we get an average velocity of 220 divided by 4, which is 55 miles per hour in the eastward direction. Okay, very good. Matthew said it's closer to 60, yes, because the reason it's closer to 60 is because you spent 3 hours going at 60 miles per hour, whereas you only spent 1 hour going at 40 miles per hour. Okay, very good. Now, the average speed in this case is going to be exactly the same as the average velocity. And if you know why, go ahead and type it into the live chat. Okay? You know why, go ahead and type that into the live chat. And we're going to talk about our last concept for today, which is something called acceleration. Okay, so yeah, someone says because the direction is the same throughout because one direction was used. Yep, that's exactly right. So the sort of the difference between velocity and speed comes out when you're changing directions. So here we have the direction is changing. You go from left to right. So what that means is when you have displacements, you're going to have negative numbers. which is going to affect the answer. But if you're always going in the same direction, you're just adding those numbers together. So very good. Okay, so acceleration is denoted by A. And I'll give you a couple of definitions of acceleration. You have one way of saying what the acceleration is. You could say it's the rate of change of velocity. Okay, your velocity does not have to be the same. Your velocity can change. Okay, and in fact, in these problems, the velocity was changing. So acceleration is measuring the rate of change of velocity. When I took physics class in high school, my teacher said that acceleration is how fast you get fast. And that made a lot of sense to me. How fast you get fast. But that's not entirely 100% correct, because there are some other things that also count as acceleration. Because remember, acceleration is the rate of change of velocity. And velocity is not just speed, it's also direction. So another way you could accelerate is you could turn. You could change the direction of the velocity, okay? So I like to think of it as how fast you get fast or how fast you turn. All right? Turning also counts as acceleration. If you've ever been in a car and the car has taken a sharp turn and you get flung to one side of the car, that is an example of an acceleration. Okay? So the mathematical definition of acceleration is change in velocity divided by change in time. Okay? Go ahead and type it into the live chat if you know what this means. If you know what that stands for, these square brackets, go ahead and type it into the live chat. And I'm going to write down an example while I'm waiting for your response. One of the places that you probably already know about with acceleration is 0 to 60 times. You ever hear about 0 to 60 times for a car? And so let's say that a BMW goes 0 to 60 miles per hour in 4.8 seconds. What is the acceleration? Okay. Excellent. So I see that many of you typed in that in square brackets, this means units of acceleration. That is correct. And so whenever we want to learn the units of a quantity, we look at the equation that defines it. Okay. So the equation that defines acceleration is change in velocity over change in time. So the units of acceleration are going to be units of velocity divided by units of time. Units of velocity are meters per second. Units of time are seconds. And so we get that the units of acceleration are meters per second squared. Meters per second. Okay? I'm not sure I understand the question. Isn't that for a given interval? I don't understand that. We can talk more about that in the Zoom room. Okay, so first thing I want to notice here is that 60 miles per hour is not in metric, and 4.8 seconds is in metric, so we want to convert that 60 miles per hour to meters per second. So theoretically speaking, you guys learned how to do unit conversions in like chemistry class and physical science, and so I don't really like focusing on unit conversion because I think it just slows us down from the physics concept. So I'm just going to go to Google and I'm going to type in 60 miles per hour, 2 meters per second. Okay? So I encourage you to use Google to do unit conversions if necessary. And I can see that 60 miles per hour is 26.8 meters per second. All right. So now I'm going to use the formula. Acceleration is change in velocity over change in time. Change in velocity means final velocity minus initial velocity. So the final velocity was 26.8 meters per second. The initial velocity is 0, because it's 0 to 60. And then the time elapsed is 4.8 seconds. So that is going to give us an acceleration of 26.8 over 4.8. That is 5.58 meters per second. So 5.6 meters per second squared. That's our answer. Okay? So the more time it takes for you to go 0 to 60, the smaller your acceleration. Why is that? Because time elapsed is in the denominator. So the bigger that denominator gets, the smaller your acceleration is going to get. For example, my first car was a 1979 Volvo station wagon. And it was a really cool car. It had a really nice leather interior. But that car was just all problems from the moment I got it. It probably took 20 to 30 seconds to get up to 60 miles per hour. Merging on the freeway was just really scary because I literally could not get up to the freeway speed within that on-ramp distance. Okay? It was terrifying. And then about, I would say maybe a year after I got the car, it broke down and could not be revived. So, but it was a pretty sweet looking car. Let's do another example. What if we have a probe, a space probe, traveling at 100 meters per second, reverses its direction. Or I should say reverses its velocity in 4 seconds. What is the acceleration? Okay? So acceleration is change in velocity over change in time. Okay? Who disliked the video? It's okay. It was probably my mom. My mom watches my videos sometimes. That's another reason why I do YouTube Live, is my mom can watch me. She lives in another state. Maybe she's lonely and she can watch my teaching. Okay, so here's the thing. If you reverse your velocity, that means the velocity becomes negative what it was, the opposite. So the final velocity is going to be negative 100 meters per second. Okay? The initial velocity is 100 meters per second in the forward direction, so that's plus 100. And then the time elapsed is 4 seconds. Okay? So one of the things you have to be careful about with accelerations is we could have negative signs. We could have double negatives. Okay? So this is going to give me minus 200 meters per second in 4 seconds, which is an acceleration of negative 50 meters per second squared. So having a negative acceleration is completely possible. That means that your velocity is changing to a more negative value. A positive acceleration means your velocity is changing to a more positive value. Okay? So that is my lesson for today. And so I will meet you at the Zoom room. Okay? Bye.